Hello everyone. In this video we are going to talk about modern data warehouse. To understand modern data warehouse, let's understand why do we need modern data warehouse. So the reason for traditional data warehouse to not work better or probably solve all the problems that the industries are facing today is because it is only able to handle structured data and also because it cannot handle big data. And big data is different in terms of the architecture and the conventional data handling techniques. And here we are going to talk about such massive volumes of rapidly changing information streams, such as data warehouse isn't able to accommodate those, right? So the architecture that can handle such an amount of data is known as data lake. So a data lake uses a ETL approach, swapping, transform, and load operations, supporting large storage and scalable computing. Right? A data lake starts um, data loading immediately after extracting it, handling raw, often unstructured data. So if you ask me like what is the example of a data lake, S3 bucket that you might have used and heard about in AWS. So that's also an example of a data lake. Okay. So a data lake is worth building in those projects that are going to scale and would need a more advanced architecture. All right. So let's look at a few of the properties of a data lake. Vast pool for saving data in its native unprocessed form. It uses the ETL approach to swap, transform, and load. For projects that need scaling, we need data warehouse, data lake, and we use it for when the purpose is unknown. Okay, so those kind of scenarios where we use a data lake. Let's look at the pipeline for a data lake and how that has been set up. Okay. So here from the data warehouse after ETL, the data is loaded to the data warehouse and then sent to data marts for specific use of business users primarily. And from data sources using ETL, data is first loaded to data lakes in its raw form and then transformed, which is further used for data scientists for prediction. Okay. ETL is modern variation, and ELT is basically a modern variation of older process of extract, transform, and load. Instead of extract, transform, and load, we do extract, loading, and then transform in the warehouse itself. So, in which transformation takes place before the data is loaded. Um, okay, so, running transformations before the load phase results in more complex data replication process. That's the reason that in some of the modern data warehouses, we do the transformation later rather than doing it before loading into the warehouse. So, this helps the data scientist get better insights. So this helps the data scientist to get better insights about data. Okay, I hope that makes it clear. Let's look at some of the examples of modern data warehouse. So we are moving from self-hosted or the physical machines to the machines that are serverless, basically giving liberty of not having a server or not needing a server to be deployed from scratch. So some of the self-hosted servers like Presto, Redshift warehouses like Redshift RA3 and Snowflake, and then go for BigQuery and BigQuery on demand. So this is how the serverless architectures are kind of today evolving. So implementing for big data and hosting it in the cloud are the features of modern data warehouse. The most common modern data warehouse tools are here. On the self-hosted end of spectrum is Presto, where the user is responsible for provisioning servers and detailed configuration of the Presto cluster. Presto is open source, unlike the other commercial systems in this benchmark, which is important to some users. Pre-RA3 Redshift is somewhat more fully managed, but still requires the user to configure individual compute clusters with a fixed amount of memory, compute and storage, etc. Redshift RA3 brings Redshift closer to the user experience of Snowflake by separating compute from storage. There are many small differences that these modern data warehouses are presenting and as in service to the users. Snowflake is a nearly serverless experience. The user only configures the size and the number of compute clusters. Every compute cluster sees the same data, and compute cluster can be created and removed in seconds. Snowflake has several pricing tiers associated with different features. Our calculations are based on the chipset tier standard, right? So if you expect to use enterprise or business critical or for your workload, your cost will be 1.5 to 2x higher. BigQuery flat rate is a similar to Snowflake, except there is no concept of compute cluster, just a configurable number of compute slots. Similarly, there is a BigQuery on demand, that's fully serverless application that we can deploy and just start using it. All right, so that's all about the modern data warehouse and the technologies that's been currently in use, and this kind of concludes that how the modern data warehouses are being used today. Okay, so thanks for watching this video, and I'll see you in the next video. Bye.